Okay, for part three, this is pretty much the situation. And what we need to do is, after the patient leave the exam room, they have a percentage goes to the so-called inpatient bed. Okay, inpatient bed. This is the service. So the patient goes here, determine if they want to be boarding. If they need to be boarding to the inpatient area, they go in the upward. And I see student have the several different layout. That's fine. If the patient needs to board, go in this direction. If the patient don't need to board, goes to the cashier and check out. Okay. If you come up to this portion and then you check, for example, if the current simulation time is after what, 4 o'clock, and then if it's off at 4 o'clock, and then it directly goes to transfer to other facility. If it's before 4 o'clock, they can still boarding. Okay, so this part is fairly easy using bilink way, based on the current simulation time, and redirect them to each one of them. And also, upon here, before they actually board, and they need to see if the size of the bed they are fitting this patient have anything available. So we're using a specific so-called model entity, bed type, resources, capacity remaining. If there's remaining capacity still greater than 0, you go ahead board. If their bed size is already full, then it also goes to transfer. So they go to the same place for transfer. Okay. To set this up is a little bit tricky. You need to go to model entity portion, define a state variable, and using a object reference called object reference. Here I have called bed type. Since the bed resource is an object, so I'm referring to an object called bed type. Okay. All right. So upon the arrival of a patient, for example, schedule or walk-in, and after they been created, before they leave the source, I'm running a best size type of process, add-on process. Let's take a look at this process. This process is fairly easy. Okay, zoom in a little bit. First, we decide if the patient type based on the data. Okay. Is that here? Okay. I have a column called inpatient mix. Okay. If it's regular, they have no chance to be boarding. If it's a acute patient, they have a 50%. I think urgent, they have a 70%. Everybody okay with this? Okay. So I'm using this probability to do this, decide if they are actually going this way. So it's a probability based on the inpatient mix column. If they're not boarding, I go down here, I assign the patient bed type equals to nothing, meaning this patient is not going to board. So I'm assigning their resources equals to nothing. Then I determine if the patient's height and weight are within certain range. So determine the patient's height and patient's weight and storage in model entity patient weight and model entity patient height state variables using this. Why I'm storing in the model entity in the very beginning, because I save those, they will not need to be changed for the downstream. Okay, so based on the patient height and weight column, and you can generate their corresponding height and weight. Question for me. All right. And once you've done that, you can determine their height and weight. If it's, for example, less than the bed limitation 1 and the weight limitation 1 for high. So here you have a bed limitation with what column called high, column for weight for each patient. You compare with this table, okay? If it's 1, which is pediatric, is lower than that, you assign them to pediatric bed. So the patient bed type for that particular patient is a pediatric bed. If you compare them to the second rows of height and weight in that table, if it is less than that, you assign the bed type to, is greater than this limit, and you assign them to bariatric bed. Otherwise, just assign them to regular bed. Everybody okay with me? Okay. So this is all you have to do on here. Once a patient's model entity bed type is defined, and rest of these are the same, upon here, you will have to decide if the patient's boarding. That's easy. If the patient's bed type equal to nothing, of course, this patient is not boarding. If on here the patient's bed type is not equal to nothing, meaning this patient has a potential to board. And then you go up here, determine the current time of the simulation, and see if the patient need to be transferred, or then come up to this node, and you determine whatever bed type this patient was assigned to, and their capacity, remaining capacity is greater than 0. If there is still empty bed for that capacity, then you go ahead right here. Okay, go ahead, go into this server. And this server just really easy, just using the model entity bed type, and you seize and release those as a secondary resources for that. So with that set bed type of one process upon patient's arrival, simplify a lot of the logic for your bed assignment logic or inpatient logic. Question for me on part 3? Oh, no, is before they leave the source. You can do that in the exam room. That's fine too, but I went ahead just run that before they leave the source. Make sense? You can also do it within the exam room. For example, after processing of this. The reason I haven't added here, because after processing an exam room, the after processing add-on process is release the exam room. So if you really want to do that, let me go through this. Sorry. Where is that? Okay, this one. So you delay for addressing time, and you release the exam room key and basically resource, and then you can actually do execute if you really want. Execute what set bed type, bed size. You understand what I'm trying to say? You can do that too. So since there are two separate processes, and you can actually using the execute key to execute that. at the add-on after process. So since I already run it in when the patient leave the source objects, so I don't have to run it here. You can choose to run it here. All right. Any other question for part 3 before we move on? Okay, part 4, fairly easy. All you have to do is set up the 4 different material: engine, frame, wheels, and fastener. And then you set up a so-called bill of material, okay, including these 4 and type of material. So you need 1 engine, 1 frame, 6 fastener, 2 wheels to make a snowblower. And then you have a snowblower as a final product you want. So this is all you have to do for part 4. And within the workstation, since you have a table called the distributor destination 0 through 4, and you can have an order quantity right here to generate. So upon arrival, you generate the model entity order amount, and using that tables and so on and so forth. Of course, you can using either set row or using table references right here to set which distributor it is based on the mixture column. Once you set the order amount and store it within the model entity state variable, and you can actually do it here. So over here, you can either do a table destination order quantity, or you can do a model entity order amount. Amount order, isn't it? Amount order. So either one of them will work. All right. And you have to make sure the processing batch is equals to 1 at a time, so it will run through as many quantity in this process. If you don't have anything right here, and that means the entire batch is processed one time using this processing time. If you say 1 right here, it represents the processing time equals to whatever triangular distribution between 4 to 7 minutes, most likely 5 minutes, times the order quantity. Okay. And since you process 1 at a time, and you consume the bill of material 1 at a time, and you produce the snowblower 1 at a time, since you process your entire order 1 at a time. Did that make sense? You can also process the entire order as one batch. So if you don't have anything right here, and that means the entire order quantity was processing at the same time. And then over here, you need to consume the order quantity and produce the order quantity. But I find out this process entire batch in one batch will have some side effect, which is they have to wait until all the materials are ready before they start processing your order. You understand what I'm trying to say? If it's 1 at a time, it will consume your bill of material and produce snow blower 1 at a time. It will deplete your inventory 1 at a time as well. So it gives you opportunity, even your inventory level is not there, and then they still can produce a portion of it until the raw material arrive later on. That's in part 5 and 5A and 5B. Question for me. I want to go through these real quick since I already find some of the student didn't follow the lecture. Part 5, actually 5A, isn't it? No, 5A is now you adding one more workstation, or adding one more workstation, and they are identical basically. And here you want to equally assign your order to one or the other. So what you do is you adding a so-called list called cycle list, using defined as a node list, okay, using the input node of assembly 1 and assembly 2 workstation. And then at the output node of the source, you need to do is you need to select them based on the list and using cyclic process. Make sense? Okay, and that's the list. And you can have multiple choices, either random or smallest value, largest value based on the capacity. Here I'm just using cyclic, meaning first one goes to assembly 1, second one goes to assembly 2, third one goes to assembly 1, the fourth one go to assembly 2. And the inter-arrival time should be, what is it? 8 hours, and per arrival you have 4 orders. I saw some of the student actually using 4 hours, which is the modification from part 4 require you to do. I didn't deduct any point. Is you're probably getting twice as much of a production in that case, or close to twice of the production that way. But this is not a major issue right here. 5A, actually, you need to define a timer called Restock Timer and running every hours to the hours. And also you run initially at the 0 when simulation start begins. And then whenever this event trigger, restart timer event trigger, you run a process to restock your inventory for 4 different, okay, stock. And this is what we call the order up to level. And you don't do, I saw some of the students doing, what is it? And we'll, for example, dot quantity in stock plus the order quantity. So this is not a so-called order up to level, meaning you adding the order quantity on top of your current inventory. When we refer order up to level, meaning you have a fixed amount of storage. You always fill your inventory up to this level. All right. Question? Five B. It's about the same. Sorry, Sarah, I'm keep using your model for no reason. I just randomly pick before class. All right, similar situation right here. 2 workstation consuming the same. Here I define in part 5B, you need to define 4 of the monitor. Each one of the monitor the corresponding material level. When the quantity in stock cross state change from positive to negative compared to the reordering point, meaning if the quantity in stock is higher than the reordering point, and then this is a positive. If they becomes a negative, which means quantity in stock minus the reordering point becomes negative, it triggers an event. So each time the inventory fall below the reordering point, it will trigger an event. And this event is called monitor engine dot whatever event is. So over here, this is a replenishment logic. You have 4 sources to generate orders for each reorder for each one of the material. And for example, engine is triggered by this monitor engine dot event. If the engine's currently quantity in stock fall below the reordering point, it triggers this event. It will create in one entity called entity engine. Okay, and it gives a lead time on the time path over here. When they reach to the end of the path, it runs a process, actually produce the corresponding quantity for the engine. So this is reorder quantity right here. Doing really good. So you have 4 of those. And I see some of the students using one single add-on process, use so-called customer token driven process. That's fine too. That's an excellent job. But here you're using 4 different processes are also okay. Everybody okay with me? If nobody complained, let's move on to the term project. Okay. The term projects assignment. I go back to the assignment portion. I learned it from the last semester, and it's probably easier just to, chop the entire term project into several milestones I want to introduce today to your team. First one is the delegation of a responsibility, and you need to come up with a 1-page or 2-page summary for each one of the items I have listed. Okay, let me go through that. Fairly easy. Term project. Give me a second to open the competition problem statement. All right. So these are having 12 so-called responsibility I listed. If you feel you will have more, you can add, but at least these 12. Excuse me. And these 12 responsibility actually coming from the problem description and in here. So you have basically the facility layout of the system, the manufacturing processes. I'm going to shrink this a little bit. Manufacturing processes, and then the employees, okay, and current state buffering and inventory system, and the supplier receiving and quality concern, and product demands, how you forecast, and future state of buffering and inventory system, and analyze the projects, how you're going to analyze the project, and what are your deliverable. All right. And finally, you have a challenging problem also in the bag. Okay. So please within a week, I think next Tuesday, between now and next Tuesday, come up with uh, your responsibility assignment for each student. So each one of the items here, I will need to see a name of the student on your team or several students on your team responsible for that item. And the main purpose for the first assignment is just for everybody to read the problem description to begin with and understanding what needs to be done, the magnitude of the projects, and so on and so forth. Any question for me on this portion? Okay. If not, we need to talk about quickly next week. Is that next week? April 15th. Next Thursday, we will have a second midterm exam covering homework 2 and 3 both. So please go over your homework 2 and 3. So I spent time to giving you detail on homework 3, even though what's going to happen, why I'm going over those, okay? So make sure you review your homework 3 and 2 whenever I grade it. I'm contemplating, should I give starting the exam like 9:20 for the exam, our class time, or you want me to start with 11 again, based on your schedule? Any input? Don't care? That's fine. That's fine. Do you want me to start the exam with some live discussion, or I think don't need. You guys already know what's going on. So we just start this directly on 9:20. I will set at 9:20 and give you plenty of time, uh, an hour and a half, similar to last time, isn't it? Okay. And it will go over a little bit, but if you need to have a time conflict, just drop me a note before the exam. I will rearrange your exam some other time slot you are available. Okay. So let's start 9:20 this time, um, and see how far you can go before you have to leave for another class. And then we give you more time for continuation of the exam, or you wanted to reschedule your exam for entirely different time slot, that's fine.